please welcome on stage Stylianos Mamagkakis, Manager Strategic Business Development, Samsung Europe.
Thank you very much for the introduction. Thank the organizers for inviting me. One thing that I would like very much to highlight right from the start is, before you start asking me about the new S6 and Galaxy Tab and so on, is that actually I'm representing Samsung Semiconductor Europe. And a semiconductor is actually the part which enables the technology and enables all the devices that you have. So there might be a 40% chance that you own a Samsung phone or tablet or something like that, but there is a 100% chance that you actually have one device which has inside either a Samsung display or a Samsung memory or some sort of Samsung processor, Samsung battery, and so on and so forth. So, next slide. Okay. So I needed to do this introduction and to say that we're coming actually from the business to business, the component part of Samsung Semiconductors, where actually Samsung has a very big past and very big history. So probably you do not know, Samsung Semiconductor is the second biggest semiconductor company in the world after Intel, with memory in particular being the leading product for more than 20 years, having almost half the share of the memory market. And it is about the story of the components which enable these IoT and cloud applications that I'm going to talk about here today. Because actually, it is these components which define the trade-offs and who define what can be done in a device, what can be done in the backend, what can be done in the data center, and actually also as a result define the business models, what data gets stored where, who owns what, how the computation is done, and so on and so forth. So as an example, I'm using this picture where in the background you see a car which nowadays is connected. I use here the picture of a wearable device, a smartwatch, and then also what you have in the back office where you have the data center which calculates all the data. So you have three main components being computation, storage, and displays. And these three components of the story define what gets done where, who owns what, and what business models are actually enabled. And you need to find a balance between these components, whether it is in your IoT device or whether it is in your data center, in order to drive the right business model forward. So I will start actually with the wearables. And then for the wearables, here you can see an example of a platform of what you have today in a smartwatch, but also other smart wearable devices. And there, of course, you have a component which has to do with connectivity, a secure element, a display, many times a flexible display also today, your application processor, which is the heart, where all the computation is done, and then also some sensors. These have to be, of course, very power efficient and very thin, and actually it is exactly this balance between processing, power, and also size and thinness, which define in the end what actually will get in this device in order to make it something which is nice for the end consumer to have and to wear. And there you see an example of a bioprocessor. Actually, this is the latest product from Samsung, as well as a traditional application processor. And there you see actually the two ends of this processing spectrum. A bioprocessor is a very small processor. It's about 20 times smaller than an actual application processor. So this is something that you might still be able to use in your mobile phone or in your smartwatch, but then not in a smart necklace, for example. Well, a bioprocessor being 20% smaller and actually also having about half the energy consumption is something that you can use in many more sizes and formats for the end customer. So depending on actually what application you want to drive, and depending also in what end user scenario you have, there is a very broad spectrum already today, which as a device manufacturer you need to choose. And then moving also into another important aspect, which has to do with thinness and with fashion, is also you need to make sure that your device is something, again, which is nice for the end customer to wear. So here, as an example, I bring the packets on-package memory. And this is actually a memory which you put on top of an application processor and offer it as a package, which immediately makes your device much more thin and much more smaller. So it is actually also devices and memories like that which enable the end user to store also data in his own end device. And then, of course, this has also implications in respect with the business model, because by having the end user having the capability to actually having on device his data, he can also choose not to transmit it at all and not to give access to them to any other third parties, as we have seen before. And then finally, I would like also to show a little bit about displays, because actually this is where the end user will see the information which is displayed. And there also from Samsung, we have a very clear vision in respect with the future. So what you already see in the market are curved displays and going also into bented displays. This is a technology which is supported by our active matrix organic LED displays. And actually, we have a very clear vision in respect with the future that we are going towards even foldable and stretchable displays. So having all these different size formats in order to be able to display data, this is also a very critical enabling component for your end IoT device, in this case, wearables. So I will also just briefly show that for automotive, it is also a similar story with your connected car. There as well, you have key components like memory, processors, displays, LEDs, and so on, which drive innovation today and make a car itself a connected device which displays and collects data at the same time. And moving on to the back end of the story, it is actually where there is a decision either by the end user, the consumer, or by the application memory to process this data not on the device itself, because of the different limitations and trade-offs that we have discussed in the past. Actually, we see that this is something which is moved back to the cloud. So when there is a decision whether for business model from the end user to move things into the cloud, there you have also a variety of components which play a significant role, most importantly the processor, but then also for storage and storage of the data, as we discussed before, there we see performance, energy consumption playing a critical role, as well as a total amount of storage that can be used for all these IoT applications, which in the end collect data from each and every single user. So there, what is important also to understand is that you need to make a lot of choices based, again, on the trade-offs that you have in respect with performance, energy consumption, data retention, and different workloads that you have driving these applications, the workloads which are coming from IoT devices. And then based on this, you need to make decisions also in respect with the storage that you are actually going to use in your data center, in the backend, where all this IoT data will eventually be collected if they are not processed and stored on the device itself. And there, the trend that we see with the performance is very significant, and there we see specific solid-state drives driving this. And then here I have PCI NVMe examples where you can have difference up to 2-3 times the speed. And then also new technologies like vertical NAND, which again, as a semiconductor manufacturer for Samsung, this is very important, where you can drive density 2 times up and power consumption to a half. So to summarize, actually, it is very important, the end applications for IoT as well as then the backend for the cloud, but it is very important also as a designer to understand the limitations which are given by the components which either are used to build the IoT devices as well as your data center which is in the back. And we at Samsung, we are manufacturers of all these components. And what we see today is we see that in the market there is a very wide range of requirements. And we see displays everywhere. And this as well then being using either on-device processing and then also data stored on the device itself, or actually using the storage and the processing power of a data center into the cloud in order to drive these IoT applications. So as a potential designer of IoT devices, or as a data center, somebody who runs a data center, then my key message is to actually to be able to understand these trade-offs in respect with sizes, in respect with performance, power consumption, and based on your end application to make the right decision in the order also to be appealing to the final consumer of this device and applications. So I will be here also for the whole day, so you can contact me also after the break for any further questions. Thank you very much.